Okay, boys and girls, welcome back. This is your second favorite 8th grade math teacher again, Mr. Noll, coming from Detroit, Michigan right now, where I'm anxiously awaiting my wife's surgery. So, hey, we're talking about functional relationships and graphing. So if you open up your notebook to the functional relationship notes, we're going to go through it and get you guys through it. So taking a look at page 1, functional relationships. It says, did you know you can sketch graphs to model real life situations? The graphs do not need to be points or numbers. Whoa. Yeah, baby. So it says, grab a partner with a partner, brainstorm some real life situations that could be modeled by this graph. Okay, pause this video, talk to your partner, come up with a couple situations that could be modeled by that graph. Okay, welcome back. A couple things that I came up with is looking at that graph, and pardon my writing, it's not always the easiest thing to write on this. We could talk about speed when you are, running. This graph over here could be described as, we're standing still right here. I start running. My speed increases until I get to a point where I'm tired, and then my speed decreases till I come to a rest, and then my speed increases again, decreases again, and then increases once again, and then decreases. So we could look at it as speed when you're running. We could look at it as the amount of water in the pool. We could look at all kinds of things. As you're filling up your bathtub, water goes into the bathtub, then you drain it out. Then you put some more water back in, then it drains out. Then you put some other water back in, all kinds of that good stuff. Okay, if we look down at the bottom part, now it says on your own. It says sketch a graph to model this situation. A dog is sound asleep when she hears the doorbell ring. She quickly runs to the door and stares out the door. As the visitor walks away, the dog slowly walks from window to window, searching for whoever rang the doorbell. She eventually gives up and lays back down and goes back to sleep. Now, the first thing we need to think about are the two variables that we are comparing together. Okay? In this case, on the x-axis, we are comparing the amount of time, and on the y-axis, we are talking about the distance. Ooh, nice writing. The dog is from the bed, okay? So the distance the dog from bed is just how quickly I will write that. Okay, so we look at the story and we graph. Now, first off, the dog is in its bed, so its distance from the bed when it starts is right down there at the origin at 0, 0. She quickly runs to the door, so we're going to show a quick speed gets to the door, and it says, and stares out the door for a little bit of time. So when she stares out the door, that distance stays the same. Then it says the dog walks slowly, or the dog slowly walks from window to window. Now those windows could be closer or farther away. I would say those windows are closer to the dog's bed. So walking slowly from door to door, from window to window, searching for whoever rang the door. She goes to a window, she searches for another window, and eventually she goes back to her bed and lays down. So that's where my line shows going back to the bed, laying down. All right, on to the next page. Maybe. There it goes. Move. Move, please. This thing is not moving. There we go. Next page, graphing functional relationships. Once again, same type of information. Emma started filling an empty bathtub with water. After a few minutes, she stopped filling the tub. After a few minutes later, she drained some water out of the tub. She immediately plugged the bathtub up and filled it all the way to the top. She left the water in the tub for quite some time before draining it all the way. So once again, we need to identify variables. Right now we are comparing the amount of time to the amount of water in the tub. Starting over, it says, hey, we're filling the tub. So once again, I'm starting down here at the origin, filling the amount of water. So the amount of water is going up in the tub. She stopped, after a few minutes, she stopped filling the tub. So the amount of water in the tub stayed the same. A few minutes later, she drained some of the water out of the tub. So now the water is going down. She immediately plugged the bathtub, so there is no time where it flattens out, and filled it all the way to the top. So we filled the water all the way to the top, and then it says she left the water in the tub for quite some time. So unfortunately, I'm running out of room on my graph before draining all the way. So then eventually, we would drain that water out of the tub. Sorry, mine came off the graph. Number 2, Ryan rode his bike to school. He pedaled as fast as he could for 2 minutes, then stopped to tie his shoe. He pedaled as fast as he could again for another minute before slowing down for 5 minutes. He pedaled again as fast as he could until he arrived at school 2 minutes later. So again, 2 variables that we are comparing together. First off, on the x-axis, time. On the y-axis is distance from home. So, starting out, first off, Ryan is starting at home. So again, starting at the origin, it says he pedaled as fast as he could for 2 minutes. So I'm just going to show going fast as he could for 2 minutes. Then stopped to tie his shoe. Well, when he stopped to tie his shoe, his distance from home stayed the same. He pedaled as fast as he could for another minute before slowing down for 5 minutes. So he went real fast for a minute, and then he slowed down. Now notice, just because he slowed down, that line is not going down because his distance from home is still increasing. He pedaled again as fast as he could until he arrived at school 2 minutes later. So after 5 minutes, he started pedaling faster, so his speed went up again until he got to school. Number 3, a little girl slowly climbs a ladder to a really tall slide. Once she gets to the top, she pauses for a few moments before sliding down quickly. Once she gets to the bottom, she realizes how fun the slide really is, so she ran up the ladder to the top without hesitation, quickly slid down again. So when we look at that situation, first off, 2 variables, time on the x-axis, and the height of the slide is on the y-axis. So when we compare these 2 together, first off, she climbs a ladder on a really tall slide. Once she gets to the top, she pauses. So we're starting down here. She's starting on the ground, climbs up the ladder, gets to the top, pauses for a little while before sliding down quickly. So the height slides down quickly to the bottom. Once she gets to the bottom, she realized how fun the slide really is, so she ran up the ladder. So now she went up the ladder real quick and without I went too far. Sorry. Let me get rid of that. There it is. She ran up to the ladder, and then once she got to the top without hesitating, she slid back down. Okay, so then moving on, in this page you will need to gotten from the sub or from Mr. Fricky. Okay, what I want you to do is read over those examples, label the x-axis and y-axis, draw in those graphs, and then once you're done drawing the graphs, check your answer or unpause this video, and you can check your answer with my answers on those 4. Okay, welcome back. Let's take a look at example 1, and hopefully your graph looks like mine or similar to mine. First off, we're going to start out with example 1. Time will be on the x-axis. Heart rate would go on the y-axis. Your graph would not start at the origin because your heart rate before exercising is not 0. Your heart rate would start somewhere up here, okay, depending on where you put it. But your heart rate increased from warm-up exercises. You then maintained a heart rate, and then you had a cool down time where your heart rate cooled down or slowed down, and eventually got to a point where your heart rate stayed the same. Example 1. Example number 2, talking about Mary and her distance from home. So our 2 variables, once again, time and distance, and this distance represents the distance Mary is away from her home. Mary would start at her house, so in this case at the origin. She walks for a little while, stops, talks to her friends. She then walks, or she ran at a faster pace, walking at a faster pace to get to the library. She stayed at the library for a while, and then it says she ran home, so she ran home, so quickly went back home until she got back to her house. Example number 3, or I'm sorry, the first one on the back, talking about the giraffe being born. A giraffe is born 6 feet tall. Okay, once again, 2 variables, time, and this would be the height of the giraffe. Once again, the giraffe is born 6 feet tall, so this line would not start at the origin. This line would start somewhere up on the y-axis. It grows at a steady rate until it's fully grown. So that giraffe grows and grows and grows until it reaches its adult height, and then the adult height stays the same. Finally, number 2, Number 2, Joseph is skydiving. At first he is free falling rapidly, and then he releases his parachute until he reaches the ground. 2 variables, once again, time on the x-axis, and on the y-axis is the height from the ground. So if we take a look, he's flying in the airplane, so the height from the ground is going to start up pretty high. Now it starts out, he free falls, so he's going to fall really fast until he lets out his parachute. Once he lets out his parachute, he's going to slowly, gradually make it to the ground. So your graph should look something similar to that. Okay, pause the video once again. Read these 3 situations over, match the graph with the correct description. Unpause it when you're ready for the answers. Okay, welcome back. Number 1 says a person leaves home, drives through town, then on the highway, and finally stops at a rest area. Number 2, a person leaves home, drives to the other end of town, and then returns home. And then number 3, a person walks to a friend's house where she stays overnight. So when I look at this one, choose the graph that best represents each situation. Number 1, a person leaves home, then drives through town, then on the highway, and finally stops at a rest area. That's going to go and match graph letter A. A person leaves home, drives to the other end of town, buys grocery, and returns home. That is described by letter C, because on graph letter C, that's the only one that returns home. Number 3, I'm not the smartest guy in the world, but if I haven't used graph B yet, a person walks to a friend's house where she stays overnight. So we can see on graph B, this person walking to a friend's house, gets to the friend's house, and stays there the rest of the night. Doesn't get any closer to home, any further from home, stays there. Okay, folks, hopefully you enjoyed the notes for functional relationships, and drawing and writing some stories, or I should say graphing some stories. Thank you, and I hope to see you guys soon. Peace out.